and those are still my Twitter handles. I hope you had a great, well-rested afternoon yesterday. So as usual, today, what we're going to learn through this session is the following. You learn more about resistors. We already know what are resistors, and then you'll also learn more about diodes, the skills focus as to how to actually use the information that I've been teaching you in the past week and this week. So we'll also look at the factors that affect resistance in the circuit. We did look at those a bit yesterday. So I need volunteers to assist me with our homework corrections. Yesterday we had a homework. Who wants to assist us? Who wants to assist us with our homework from yesterday? Who wants to assist us with our homework from yesterday? Do I have someone? Yes, Amra, let's go. Open your mic and then we're working.
So are we doing the table?
Yes.
Okay.
Let's go.
So number 1 was the electric stove.
Yes, the electric stove. Where do we get our
resistor is under the bottom plate or on all heater elements?
Yes, true. Resistor is under
the bottom is at the bottom of the plates or on all heater elements?
Yes. Under the bottom plate. Under the bottom plate. What else you were supposed to tell us there?
And what is the resistor made of? It's made of nichrome wires.
What wires?
Nichrome or nichrome.
Nichrome. Okay, nichrome, yes. Nichrome wires, yes. Nichrome wires. And then 2.
The light bulb.
Yes.
The resistor is at the tungsten filament.
Yes, tungsten filament. And
it is made of tungsten.
Tungsten. Thank you so much, Amra. And then number 3.
The toasters. I don't know where the resistor is.
So the toaster is in the what you call it as at the it's what type of
is it on the bread plates?
Yes, and then what is what is it
made of?
It's
the same as the electric stove, the nichrome.
Nichrome, ne? So it's
Yes.
nichrome. It's made of the nichrome, but it's nichrome attached to electromagnet. So why is it attached to electromagnet? So that when it can no longer take electromagnet, when it is attached to an electromagnet, so that it can switch off the toaster and the bread jumps off.
Oh.
That's how yes. And then number 4.
Electrical bar heater. I don't know
Yes.
where the resistor for that is either. But it's made of metal alloy wires and non-metallic carbon.
So it's on the filament. It's on the filament.
On the
filament. And then you have seen when you're switching off the heater with it turns a little bit darker until it is no longer red. So it is there.
Yes.
And you said it is made of
metal alloy wires and non-metallic carbon.
Yes. Metal
alloy wire.
Alloy. Oh, spelling?
ALLOY.
Yes, alloy wire.
ALLOY.
Yes. And then number 5.
Electric fan.
Yes.
The resistor is on the radiator.
Yes, resistor is on the radiator. Resistor. And then what is it made of?
It's made of quartz tube with tungsten resistor filament.
Yes. Or you can say it's cigar. They said it's cigar tube shaped.
Oh,
So it's a cigar tube shaped resistor. That's where it is. And then let us look at number 6.
the last one, electric iron.
Yes, where is it mounted?
It's on the sole plate.
Yes, it's on the sole, directly on the sole plate, directly on the sole plate. Yes.
And it is filled with it's hydrogen filled, so it's made of hydrogen.
Yes, hydrogen. Thank you so much, Amra.
So.
Let's see if they've got any questions so that we can don't go. Or just ask if anyone has questions. Then this is a resistor. Okay. Grade 9s, anyone of you has a question so that Amra and I can answer you? Any questions, grade 9s? Okay, Amra, there are no questions. Let's continue with today's lesson.
Okay, thank you, sir.
You're most welcome, Amra. So grade 9s, yesterday we spoke of the resistors. We all know that the resistors now, they actually oppose the flow of current in towards their destination. And then we also say now today I want us to look at special resistors. So when we're talking about special resistors, are made for creating a very specific type of resistance that instead they're inserted into electronic devices to maintain a stable resistance value. For example, Amra and I have already discussed about we've already discussed about the toaster. So the toaster will have a special resistor, and that special resistor is called is of electromagnet. So now what happens is that as the current is passing through via the conductors, and then it will get hot, and then once it is hot to a certain degree, and then these special resistors will stop the current from flowing through. Unlike when you are turning on the lights in your houses, you have to actually now say, I want to sleep, and then switch it off, and then stop the current from flowing through. These ones, once the temperature is high, they will automatically stop. Then those type of resistors, we say they are electromagnetic elements. And then we also look at when the temperature of the environment changes. When the temperature of the environment changes. Have you ever seen the street poles? Have you ever seen the street poles? I, growing up, I thought, someone was sitting somewhere in this big room, and then would switch on the street poles when it's 6 in the evening, and then when it's 6 in the morning, he or she will obviously have to switch them off again. But let us continue and see how is that happening without a person controlling that, because there is no one who actually switch off the street poles and switch them on. But this is what happens. They say resistors provide useful energy transfer. So they are also used to control the flow of current in a circuit, and they provide useful energy transfer. Let us look at the example. The element of an electric kettle turns electric energy into heat energy that is used to boil water. Are we clear? So now the current, once it reaches the element in a kettle, it is now converted to heat energy. Remember, it is a potential energy when it is stored in a cell, and then once it starts moving through the conductors, it changes to kinetic energy. And then now when it reaches its destination, which is an element of the kettle, it will change now from kinetic energy to heat energy. And then that heat energy will boil water. Remember, we spoke of electromagnetic resistors now. Then now once the kettle you know, our modern kettles now. Once the kettle starts boiling to the tea, what's happening is that now the kettle will automatically switches off. Why is it switching off? Because now it has reached a certain temperature that it says, okay, I'm cutting off. That means the resistor switches on because of heat. Remember that we said when the resistor is on, there is no flow of current. When the resistor is off, there is flow of current. Then we say variable resistors. Some resistors do not supply a fixed resistance. They have a mechanism that allows them to change their resistance. For example, dimmer light switches and volume control knobs on radios use such resistors called rheostats. So now the type of resistor that we use in our kettles, that we use to control dimming of the lights, you know, even in our cars, when you are driving in a more darker place, you will switch on a rheostat and saying, now I want bright lighters. And then when you are driving in on a street where there are street poles, you will say, okay, I don't want bright lighters. Then now you are using a rheostat to control the flow of current to their destination. Remember that when I'm talking about the lights now, dimmer lights and brighter lights, when you're controlling that, you are also using a brighter you are also using a rheostat, which is a type of a resistor as well. You are saying, I want the flow of current to be reduced or to be increased as well. Remember, we also discussed yesterday that the conductors are also it's also a type of what you call a resistor. How so? It is a type of a resistor because its length, its broadness, how big is the wire, also determines how much of current is going to flow through. Are we clear? So they say, if they can say to you, name two types of resistors, you can say conductors and rheostats. I'm sure those ones you will not forget. Let us continue grade 9. Let us continue and see what rheostats can do as well. So let us see. They say a light dependent resistor. A light dependent resistor. So now this is a third type of our special resistors. A light dependent resistor, its acronym is LDR. So it is sensitive to the amount of light that shines on it. It is normally as a higher resistance in the dark in the dark than in the light. It can be used to automatically switch the lights outside a house on or off as it gets darker or lighter. So I made an example earlier on grade 9s. I said to you, when I was growing up, I used to think, I made an example of street poles, that the street poles, what happens is at night, we all know they are bright, you know, they light. So now we see light through them, and then we call, some of us call them Apollo lights, you know, because they are out there, and then the others call them street poles. So you will see that when it gets dark, they are actually automatically turned on. When it's get lights, the lights are automatically turned off. So what does that is LDR, the light dependent resistor. So it depends on how light it is. So now what happens is that the LDR will automatically say, we allow current to flow through now because it is dark. And then in the morning, when the sunlight comes out, and then what is going to happen, the LDR will switch off the resistor now. And then when the resistor is off, the current will not flow, will now, what happens? I said to you, when the resistor is on, the current may not flow through. When the resistor is off, then the current will flow through. So that's what happens with an LDR. When it's on, the lights will obviously not be on. So now during the day, the LDR is on. the light may not come. And then at night, the LDR will be on, and then the current will will flow through. What's happening with me today? I'm making a difference between fly and flow, but with the correct term is flow. It normally has a higher resistance in the dark than in the light. So when it is dark, it will happen that it allows the flow of current. It can be used to automatically switch the lights outside a house on or off as it gets darker or lighter. So the lights will be on when it is dark, and then once it gets light, and then the lights will be off. So the LDR is sensitive to light. Then we have diodes. So the diodes, and it's a diode, then plural, it's diodes. I think so, yes, grade 9. So that's how I pronounce them, diodes. So what are diodes, grade 9s? Diodes are special electro components, electric components that control the flow of electric current. So the diodes, they are also controlling now the flow of current. They provide a very high resistance when the current flow is in one direction, and a very low resistance when the current flows in opposite direction. Are we clear on that one? The diodes provide a high resistance when the current flows in one direction, and a very low resistance when the current flows in the opposite direction. Let us see more about the diodes. So they also say that diodes allow the flow of current in one direction only. That's what they want. They want the current to flow in one direction. Those are diodes. Unlike bulb filaments and other elements in kettles, toasters, or hair dryers, diodes are not made of metal or mixtures of metals. Diodes are made of semiconductors. It's not conductors, but they are semiconductors. A light emitting diode, this is a type of diode now. So we've got now number one, which we know, we call it a light emitting diode. A light emitting diode, its acronym is LED. It's LED, so it's LED. So it's LED, LED, and then converts electrical energy into light energy. So the LED also converts electrical energy to light energy. Where do we see this LED? So we see it in traffic lights, grade 9s. It consists of many LEDs arranged in circular shapes. So they are actually arranged in circular shapes. Light sensitive diodes do the opposite of LEDs. So we also have light sensitive diodes. So the light sensitive diodes, they will work as a LDR. Remember the LDR, light dependent resistors, ne? And then I also gave you an example where we find the LDR. And then now I've made an example with the light emitting diodes. And then some of the cell phones, they also have LEDs. They also have light emitting diode. When the message comes in, you will see that blue lights busy peeping there. It's because of now there's more current is alerting you that you've got a message. And then on the robots there, you also have LEDs. You also have LEDs, light emitting diodes. So they will obviously be changing from red, green, orange. Those are light emitting diodes, grade 9s. And then what else I can tell you about light emitting diodes is that when sunlight falls on them, they can convert the light energy to electrical energy. That's why we will have solar robots, grade 9s. It's because of the light emitting diodes. We remember that we said some of the light emitting diodes are sensitive to the light. So some of the robots you will see in your car seat or in your hood, they don't work at night, they work during the day. It is because now they are controlled by they are controlled by the sunlight. And then how do these robots or these light emitting diodes change from orange to red and from red to green and so on and so forth? It is because they are of the resistor grade 9s. There's this type of resistors that are used by the robots that says, okay, we'll allow the light green to go on for a minute, and then that means once the minute it is reached, the current will be now moving to the next one, to the orange one, from green to orange, and then it will also get there. Remember that now once the current flows to a minute, it will reach a certain temperature there. Remember we spoke of the temperature, and then that means the green will now allow the current to flow to orange, and the orange after a minute will be allowed to move to red, and then after a minute red will move back to green, and so on and so forth. So grade 9, now you know how the robots are working and what type of the diodes is found in your robots grade 9s. So now I think every what you call it, if we're in a physical classroom, I would be showing you these things practically, hoping in the future I will be able to do these practicals via I will be able to do these practicals via the video, grade 9s. But it is very, very interesting to see such. But I know most of you know the robots, most of you know the street poles. So now you won't be actually wondering, why is the robot now changing green? Why is the robot now changing, and so on and so forth. You already know why do we have why do we get what you call we get lights to turn on at night. Let us look at the skills focus grade 9 for today. How to measure voltage and current. How to measure voltage and current. So now, to measure these two, you need the strength of the current in an electric circuit is measured in amperes. So now remember the current now, we know that the current is when the atoms, they start moving from the cell through the conductors to the voltage. The voltage, it's obviously found in a voltmeter. Are we clear? In a voltmeter, that's what happens. And then the measure of the unit of the voltage is amperes, grade 9. The strength of the current in an electric circuit is measured in amperes. We connect, what do? We connect an ammeter in the part of the circuit where actually now where we want to know the strength of the current. So we use the ammeter to actually see how much of a current is passing through there. Then we use an ammeter, and then we have concluded that the unit for the current, that is amperes. The unit for current is amperes. So when I say to you calculate the current, then you will say 0.5 A, which is 0.5 amperes. You don't say 0.5 current, but you say 0.5 amperes, grade 9. Remember the unit of force. What is the unit of force, grade 9? What is the unit for force? Who wants to tell us the unit for force? Who wants to tell us the unit for force, grade 9s? Do you remember what is the unit for force? Yes, the unit for force. What is the unit of force? If you're calculating the force, remember you did calculate the force earlier on. So what is the unit of force?
Newtons.
Yes.
Newton.
Thank you very much. So what is the unit for current? What is the unit for current now? It's amperes, ne? It's amperes. The unit for current is amperes. Let's continue, grade 9. An ammeter is always connected in series, grade 9. It is always connected in series, not in parallel, but in series. I did promise you that by the end of this week, or before you go back to school or whatever, we will do different types of circuits. You will see the different types of circuit when the circuit is connected in parallel or when the circuit is connected in series. You will see that. So let us continue. An ammeter is always connected in series, so in the path of the current that we want to measure, or so in the path of the current. So if you want to see how much of current is flowing from the batteries, remember I also mentioned that yesterday. I said to you, grade 9s, the cells in a circuit, they are always connected in series. So even the ammeter now, to measure the current that its unit is amperes, it is also connected in series, grade 9s. So now we spoke of the ammeter that measures the actually the current, and then the current, we said its unit is amperes. Let us look at voltage now. How to measure voltage? Voltage is measured in volts. If we want to know, we use a voltmeter. We've got a voltmeter. If we want to know what the voltage of potential difference of a circuit component is, we connect a voltmeter over the component. A voltmeter is always connected in parallel next to the component. So it is next to it. You don't connect the voltmeter in series. So in series, it becomes a string. But in parallel, they become vertically so you know that parallel lines are lines that they will never meet. So now when you connect something in parallel again, it is opposite each other. You put the voltmeter opposite to the component that you want to measure its voltage. Are we clear, grade 9? So you know now the difference between ammeter and voltmeter. A voltmeter is used to measure voltage, and then an ammeter, it is used to measure current, and the SI unit for current is amperes, and then the SI unit for voltage is V for volts. Let us recap on what we have done today, grade 9. What we have studied today, or what we've learned today, is that all conductors have some resistance. They all have some resistance. As I said to you, if you're writing a test or an exam and the examiner says to you, name 2 types of resistors, you can say LDI, which is a light, the LDR, or you can say a conductor. They are also actually a part of all. LDR is a light dependent resistor, and then you've got a conductor. We know that conductor is any cord that current flows through it, and then we say why conductors are actually a part of the resistors, because of its length. So the longer the conductor, the longer the current will be utilized along to actually get there. And then we said sometimes you can feel the cord becoming hot. That means the energy is used there. Therefore, it is a set of it is some sort of a conductor, a resistor, grade 9. And then we also learned that a resistor is a conducting material that controls the current in an electric circuit or provides useful energy. When we're talking about useful energy, I made an example of the car lights. When you actually say, I want to bright, so that I want my lights bright so that I can see the road, or I want them dim so that I don't disturb other cars. Or in your houses, you can have a knob there to control how bright your house lights can be. You know, that's why you
Sorry,
want
sir.
to. Yes.
I wanted to ask, what about the battery?
The battery is not a resistor. A battery is your energy provider. That's where actually a potential energy is stored. Remember, day before yesterday or yesterday, we spoke of potential energy and kinetic energy. So when the energy is still in a cell or in a battery there, Remember we said a cell actually it provides energy, and then we said a battery is a group of cells. So now what happens is that when the energy is still in the cell there, we say it's a potential energy. It has a potential to be used with within the circuit. So once it starts moving via the conductors, it becomes kinetic energy. What is a kinetic energy? Is the moving energy that we call it current. And then current electricity, the flow of electricity there is actually controlled by the resistors. And then we said we've got types of resistors. I even just said now your cord, the conductors, we say they are type of resistors because they also determine how much of energy is going to flow through them. I hope Lungsani is answered. And then here is your homework, grade 9. Please write it down. Please write it down. Take a picture of it, grade 9s. So in your homework there, you need to write one word for the following statements. Write one word for the following statements. A special electric component that controls the flow of electric current. A special electric current, electric component that controls the flow of electric current. Something used to automatically switch the lights outside a house on or off as it gets darker or lighter. Something that is responsible for the functioning of the volume in a radio. Something that is responsible for function. Nosipho Pungula. Yes, Nosipho, open your mic.
Yes, I can answer the first question.
Yes.
LDR, the light dependent resistor.
Yes. Yes, it is. Yes, LDR is a light dependent resistor, and then it's actually used for controlling the lights when it gets darker or light outside. That's the function. And then we know that LDR is a type of a resistor, and its function is to control the light in your bulbs when it gets darker or light. And then let's continue with our homework. Something that is responsible for the volume. Okay, something that can be identified by strips of brown or blue inside an electric device. What is that? And then we also want to know something responsible for the functioning of traffic lights. What is that? And then it is abbreviated as LDR. We've been doing that one already. So in our next lesson, grade 9s, we're going to look at factors that affect resistance in a circuit. So what affects the resistance in a circuit? And we'll also look at types of material and semiconductors. We will be looking at the length, the thickness, and temperature. How does these three conditions affect the flow of current, grade 9s? Any questions, grade 9 so far? Any questions? Remember yesterday I gave you a classwork to draw 3 cells. Nosipo, your hand is up. Talk to me.
The last question, I didn't get it properly.
Oh, let me check. Let me go back.
Types of materials, semiconductor, length, thickness, and temperature.
Which one? This one. So yesterday I asked you to draw a circuit with 3 cells and a voltmeter. I asked you to draw 3 cells and a voltmeter, and then I also gave you a classwork, and then those answers are being posted on our website at www.africateengeeks.co.za. You will find them under under natural sciences, grade 9. I thank you, grade 9s, and that's a link you can follow, and you can also follow us on our social media. If you've got any different questions, you can actually ask us, ask me on my different pages, social media handles. They are at the beginning of our lessons, and you can get the video on YouTube immediately after this. Thank you so much. Have a great day further. Bye, everyone.